Okay, earlier when we were talking about how to go from a graph of a function to its derivative, we were using critical points. And these critical points were when our derivative went to zero. Also, it's very important to recognize some other aspects of a critical point. We talked about them a little bit. Just a reminder, that's a local maximum, I'm sorry. That means if I'm standing at that point on the function, no matter what, I have to go down to get off that point, a local maximum. This is a local minimum point. Same logic. If I'm standing at that point and I want to leave that point on the function, I must go up because that is the lowest point in the neighborhood of this function. And we use that to make our graph of our derivatives because we knew that the value of our derivative, the slope of the function, the instantaneous rate of change was zero there. Let's do that in green. So we graphed our critical points and then we said, oh, my function's decreasing, negative derivative, increasing, positive derivative, but back to zero, negative derivative, but back to zero, positive derivative. And that's how we got our derivative from graph to graph using these critical points. But a critical point is either a local min or a local max. Now we're talking about creating functions that are derivatives, and we actually have formulas. And what we notice about that every one of these points on this function are x values that make my derivative go to zero. So we did this before graphically. Now we're going to use this in application in a situation like this. So it may not seem like it at first, but let's talk about this. First thing we're going to talk about is the average cost function. So I'm going to create that average cost function for you. So my average cost function is the derivative. I'm sorry, it's not my derivative. It is my total cost divided by my quantity. And I could rewrite this, and I shall. Q plus, I'm going to put the 250 in front because it's 250 over Q, which I'm going to write Q to the negative 1, plus 2Q divided by Q is just 2. This is my average cost function. And I want to minimize this function. What does it mean to minimize? Well, it's finding this type of point here and here. These are minimum points on a graph, and they occur when the function's derivative goes to zero. So we're going to do that. We've got a function, and I need to take its derivative. So average cost function prime equals 0.01Q minus 250Q squared, negative. So I subtracted 1 from my exponent. I'm now going to set this equal to 0. So this is my derivative, and I'm going to set it equal to 0. First problem I have is fractions. I don't like dealing with fractions. I'm going to get rid of the fractions by finding the lowest common denominator, which we've done before. There's only one fraction. And I'm going to multiply each and every aspect of every element in my equation by my LCD, giving me 0.01Q cubed minus 250 equals 0. So again, each one of these was multiplied by q squared. And 0 times q squared is still q squared. Now I'm going to solve for q algebraically. I'm going to add 250 to both sides. I'm going to divide both sides by that 0.1. So let's pull out the calculator, make sure we do that correctly. What do we got here? 250 divided by 0.01. And that's 25,000. Correct? Yes, it is. And I'm going to remove that exponent. It's a cubed by taking the cube root of both sides, or raise it to the 1/3 power. Same thing. So both sides. To the 1/3 power. I'm going to throw that in my calculator. So raise that thing to 1 divided by 3. Enter. 29.24 approximation. Now, let's make sure we've actually answered the question, because what I figured out is I have to have a quantity of 29.24 will make my average cost function's derivative go to 0. But was that the question? Yes. How many loaves should be baked? And that is Q in loaves. So my loaves are Q units, and it asked me how many loaves. My answer needs to be in Q. Good to go. So again, let's talk about where the average cost function came from. I took the total cost divided by, let's see, in this case, the quantity, and my quantity was Q. That's how I'm always going to find my average cost function. Total cost divided by whatever my unit is. I simplified it. I took its derivative and set it equal to 0 to find that critical point. Now, if you're in doubt whether that is the correct point or not, you can graph it to verify. I'm not going to, because I know it is the correct answer. But that's always a good thing to do, is to graph it to make sure you're looking at a minimum value and not a maximum.